Right, my topic today is the Copenhagen Spirit, a history of the Niels Bohr Institute. I, on purpose, didn't write the history of the Niels Bohr Institute because I think many such histories have already been told, and mine is just another one to add to that. I'm, in fact, very much indebted to other historians of science who, before me, have written extensive histories of the Niels Bohr Institute, among them Peter Robertson for the early years, and Finn Åserud, the former director of the Niels Bohr Archive, especially for the 1930s. So a lot of what I'm going to tell you about today is not original research I myself did per se, but there are some elements of that towards the end of my talk. Let me start by showing you a map of Europe and by telling you about the important centers in the development of quantum physics, which emerged around 1900 within a network of only a handful, very few select institutions in Europe. And quantum mechanics, which is sort of a further development of quantum theory or quantum physics, is something that was mainly developed in 3 cities. Mainly, I say, right? I mean, there are other places, but the focus was really on Copenhagen, Göttingen, and Munich. And already since the early 1920s, there was a frequent exchange of students between these 3 places, especially between Niels Bohr here in Copenhagen, Max Born in Göttingen, and Arnold Sommerfeld in Munich. Like no other place in the world, the Institut für Theoretische Physik that Niels Bohr was the first and founding director of here in Copenhagen is tied to the genesis of this theory, quantum mechanics, and also its interpretation. Most of you probably have heard of the Copenhagen interpretation. My talk consists of 3 parts. I'll start by telling you about the Niels Bohr Institute between the world wars, and I'll also give you a brief introduction into Niels Bohr's life. Then I'll have a shorter part on the Niels Bohr Institute during the German occupation. And then in part 3, I'm going to speak about the Niels Bohr Institute after World War II, which is maybe the least known of these 3 episodes. Let me dive right in. This is Niels Bohr, just to start the talk by also showing you a picture of Niels when he just had obtained his professorship at the Polytechnic Institute, the Polytechnische Lehranstalt here at Söltorp. His parents were Christian and Ellen Bohr. Christian was a famous physiologist who worked, and the whole family lived at what is now Medizinisches Museum. His younger brother Harald would become a renowned mathematician. In 1911, he wrote a PhD dissertation on what one nowadays would call solid-state physics, on electrons and metals, with the only physicist that was around in Denmark at the time, Christian Christiansen. In August 1912, he would marry Margrethe Nørlund, the sister of one of his childhood friends. And after the PhD, which was actually before marrying Margrethe Nørlund, he applied to the Carlsberg Foundation for a travel stipend to study abroad. Here you can see the Bohr family, actually at Nærumgaard, where the Adler family, the Niels Bohr's mother's family, had their summer estate. And this is the application, the grant proposal that Niels Bohr sent to the Carlsberg Foundation for his trip to England in 1911 in its entirety. So there, you can read, undertegne tillader sig at ansøge om et rejsestipendium på 2.500 kroner til et etårigt studieophold ved udenlandske universiteter, erbødigst Niels Bohr. That's it. And I think it took about 48 hours and he had the money. We just wish it was like that today, right? So Niels Bohr went to England. Not the most natural move. Many other people in the natural sciences would probably have tended to go to Germany. He was very much interested in going to England. First, he went to Cambridge to work with J.J. Thomson, and he had put high hopes into working together with Thomson. But it turned out Thomson had other things on his mind, and he couldn't really focus on one specific student who had just finished his PhD and who was very eager talking to him. So Niels Bohr actually very soon thereafter moved on to Manchester to work with Ernest Rutherford. And that really became an immensely fruitful relationship. And also, and I should add that at the beginning, I think if there is one person who was most influential on how the Niels Bohr Institute in the end turned out, that's Ernest Rutherford and his institute in Manchester. In Manchester, he worked on what was then published in 1913 as the famous trilogy, his atomic model, titled On the Constitution of Atoms and Molecules. And John Heilbronn, historian of science who still met Niels Bohr in 2016, wrote about this. Bohr would not have created his quantum atom if he had followed the standard course of Danish scientists and finished his training in Germany. Bohr managed in an intricate way to connect the traditions of theory making and model building in physics from the continent, especially Germany, and from the UK. And he sort of was a personification of that connection between these two traditions, if you will. In 1914, he finally went to Germany and started a tour, went to Göttingen and Munich, but that tour was interrupted by the outbreak of the First World War. He returned to Copenhagen and then soon thereafter to Manchester, and actually was then called to Copenhagen as the first Danish professor for theoretical physics and the second professor for physics at Copenhagen University, or rather, I already just told you, at the Polyteknisk Lehranstalt, and then eventually in 1922 received the Nobel Prize in Physics. You've probably seen pictures like this one. This is a detail from the July 1912 Manchester Memorandum, which was the basis of his trilogy that came out in 1913. And this is then a little later a much more sophisticated atomic model within the old quantum theory of the radium atom with all these orbits that form these beautiful patterns. Basically, the moment he arrived here in Copenhagen, efforts started to create an institute for theoretical physics, which eventually would happen through funding obtained by the Danish state, the Carlsberg Foundation for Experimental Equipment, and private donors. The institute, which you can see here right after opening, was opened in 1921. Bohr was the director until his death in 1962, and since 1965, the institute is called the Niels Bohr Institute after its founder. There were numerous, the central research topic in the 1920s was atomic structure and quantum theory, and then only in the 1930s this would change, and I'll talk about that too. There were numerous international staff members, guests, and students, also from Germany, which is significant because Germany had just lost World War I and was not necessarily welcome in other European countries such as France or the UK. And very often the Rask Ørsted Fund would fund these visits. And for Bohr, his activities were really a combination of an agenda for furthering Danish science and an internationalist agenda. And that this is not, that these two things are not counteracting, but actually work well together in a sort of complementary way, if you allow me the pun, is something that's quite special for Niels Bohr. So the neutrality of Denmark in World War I and also thereafter turned Copenhagen into the perfect meeting place for physicists from all nations, especially also because it was so close to the main other nations in physics, right? And then both nationally and internationally, Bohr positioned himself repeatedly against the exclusion of scientists from the losing faction of the World War I, the Central Powers. For instance, when offered the presidency of the International Union of Physics and Applied Physics, UPAP, which had just decided to exclude physicists from Germany, he said, well, then I'm not going to be the president of this international union unless you take that back, and they didn't. You might have seen, I mean, now it looks different, but the number on the facade of the institute is still the same, this number, 1920. And actually, the institute was only opened in 1921, so that's technically a mistake out there. But it's a mistake because it was a delay. It was planned to be opened in 1920, and the reasons for the delay are not that unheard of also today. It is economic troubles after World War I, strikes by construction workers, a cost explosion. The building was twice as expensive as estimated in 1917, and the equipment thrice as expensive. So one could ponder whether there are some parallels to the Niels Bohr building, which is to replace these historical halls that you see on the picture, and has been supposed to replace them for already quite some time now. This has already been mentioned by Dorte. There's celebrations this year. The reason why we didn't celebrate last year is the pandemic. And you can find out more about the celebrations at a website that the Niels Bohr Institute has made, and also a website on the Wetenskapsår. And here you can see a little picture from a celebration that has already taken place. It's the 101st birthday on the 3rd of March this year of Niels Bohr Institute, with the Crown Prince, the mayor, rector of the university, and some other dignitaries. Here's a picture of Niels Bohr's lecture in Auditorium A of the Niels Bohr Institute at Bleidamsweg 17 on the 3rd of March 1921, so 100 years before the picture I just showed you. And you can see in the background pictures of interferences of waves that he showed his audience, and actually he even gave many of them, not all of them because that would have been too expensive, a little grating where they could test for themselves what happened when lines shone on that grating or shone through that grating. And he had a platinum lamp standing here, made an experiment while opening his institute, which is very much Niels Bohr, right? The audience was also quite illustrious, but there were not many physicists or natural scientists there. Most of the people who were in attendance were the people who had given the money for the institute, which was not a small feat. But there are people here you might recognize. The most important ones, Harald Höfting, famous philosopher, and Christine Meyer, very important also for this society for the dissemination of the natural sciences, right? And one of the first two women in all of Denmark who did a master's in physics in 1892, the other woman being Hannah Adler, Niels Bohr's aunt. And they were good friends. This is from Niels Bohr's opening speech at the dedication of the Institute. I just showed you a picture of that opening speech. This institute is not intended solely for scientific research, but is also to be a homestead for the teaching of physicists. It is therefore of the greatest significance, not just to depend on the abilities and powers of a limited circle of researchers, but the task of having to introduce a constantly renewed number of younger people into the results and methods of science contributes in the highest degree to continually taking up questions for discussion from new sides. I should like to express the hope that this institute may be a place where in the course of time many young devotees of physical science may obtain guidance in their study and help to make their own contribution to the advancements of our understanding of nature and to the honor of Danish science. That's a promise, and I think, and I hope, after my talk you will, at the latest, see that a lot of this promise actually has come true, thanks to Niels Bohr. Also, it's quite remarkable for the day and age in which these words were uttered, because if you look at Germany at that time, for instance, students were primarily thought to be the assistant helpers to the big professors, right? And here, sort of the focus is on young people actually achieving something of their own, which is rather remarkable. And which is something that Ernest Rutherford in Manchester had also stressed. Here is the very international and very small original staff at Niels Bohr's Institute in 1921. As you can see, there's Danish people, there's a Hungarian, there's somebody from Norway, there's somebody from Germany, and somebody from the Netherlands. The most important people, in a way, are Bohr's assistant Henrik Anton Kramers, also known as Hans Kramers, and the German experimental physicist from Göttingen, James Franck. But of course, everybody on this picture was important. Also, Niels Bohr's longtime secretary, who actually would spend her entire life at the Institute, well beyond Niels Bohr's death. So more than 50 years. And were it not for Betty Schultz, we wouldn't have much of the documentation on Niels Bohr at the Niels Bohr archive that we have today. She sorted that material, she sorted his correspondence, and so on. But as things go, the newspaper had the following picture. So they cut some of these people off, most notably Jakob Jakobsen, who was just a lab assistant, a young researcher from Norway, Svein Rosseland, and the secretary I just spoke of, Betty Schultz. In the 1920s, basically right from the get-go, there was an extension of the institute. In 1924, more space for visitors and experimental laboratories was added, and that was already funded by the Rockefeller International Education Board, an institution that would become crucial for the further history of the institute. The Niels Bohr Institute, and I've got to say, I'm always referring to it as the Niels Bohr Institute avant la lettre, right? At that time, it was still the Institute for Theoretical Physics. I'll just do it because it's shorter. So NBI in the 1920s became the central context for the genesis and development of quantum mechanics. And the main role was played by young physicists, young postdocs, if you will, in German Knaben, the likes of Henrik Kramers, Oskar Klein, Werner Heisenberg, Wolfgang Pauli, Pascual Jordan, Paul Dirac, and Leon Rosenfeld. Those were the people in their early 20s driving physics further. It was also an important place for Soviet physicists, think of Lev Landau or George Gamow, and for non-European physicists, many of whom then went further on back to their home countries and would sort of found traditions of their own, basically inventing theoretical physics in their home countries, like Yoshio Nishina and Yoshikatsu Sugiura in Japan, or John Slater and others in the US. Copenhagen became the center of modern physics by the late 1920s, and the conferences that went along with it, the so-called Københavner Konference, they assembled the crème de la crème of modern physics, and you see one of the famous pictures down here. There's going to be more in a minute. I want to focus on one particular character here. I can't focus on them all, and this is the most interesting, probably. Werner Heisenberg, born in 1901, who died in 1976, a close collaborator of Bohr's in the 1920s and 1930s. They first met at the 1922 Göttingen Festspiele, the Bohr festival, if you will. When Bohr visited, gave a week's worth of lectures, and the young Heisenberg was in the attendance and asked a really intelligent question after one of the lectures, which got Niels Bohr to ask him on a walk, one by one, one-on-one, and then they chatted for the first time, and then very soon thereafter, Heisenberg would come visit Bohr in Copenhagen. Long stays here in Copenhagen and intensive stays here in Copenhagen. The main goal was to sharpen Bohr's well-established correspondence principle in a search for a new formulation of quantum theory. The one that we now know would have to be called quantum mechanics, or how Heisenberg also called it in 1925. When he was only 23 years old, he came up with that. We now call it matrix mechanics, right? His version of quantum mechanics that he came up with. He got the Nobel Prize for that in 1932. And I like this quote in the bottom left corner. Werner Heisenberg talking to Armin Hermann, where he said, "From Sommerfeld in Munich, I learned optimism. From the Göttingen people, Max Born, mathematics, and from Bohr, physics." I think that bodes well for Bohr. Let me zoom in on one particular episode, which I think is quite characteristic of how Heisenberg and Bohr worked together, and that's uncertainty in 1927. In March 27, Heisenberg submitted a paper to what was then the premier journal in physics, Zeitschrift für Physik, in which he formulated his famous uncertainty relation. He sent off this paper without Bohr's blessing, which was unheard of at the Bohr Institute, right? You would always take the paper to Bohr first, and then he would say, okay, send that off. So when Bohr returned, he was not necessarily amused, I mentioned to say where he was. He was on a trip to Norway, which he had actually undertaken because the discussions with Heisenberg hadn't led anywhere, and he needed a break. So when Bohr returned, he was not amused about Heisenberg's unilateral move to submit the paper, and now that's a weak word for what he did, but he convinced Heisenberg to add a note in proof to the manuscript before it was published. And in that note, Heisenberg takes back what he does in the main part of the manuscript, and that is do away with position and momentum completely as categories in which to talk about nature. And Bohr was able to convince Heisenberg, or at least to force Heisenberg to say he was convinced about that position and momentum did play a role in quantum mechanics, and that classical concepts couldn't be given up on completely, despite the limits of their applicability, which were given by the uncertainty relation. What's probably best about this episode, which had Niels Bohr furious and Werner Heisenberg in tears, is that it forced Niels Bohr to come up with his own interpretation of quantum physics and with his own take on how to make sense of quantum mechanics. And that is what is called complementarity, which came out in the famous Como lecture in the fall of 1927, and which sort of marks the end of the hot phase of the development of quantum mechanics and the beginning of what then much, much later people have begun referring to as the Copenhagen interpretation. Quite important to note, nobody in the 30s would have said, I follow the Copenhagen interpretation. That name tag only came up in the 1950s. Well, that's the uncertainty or indeterminacy relation, which you might have seen already. There's a similar one between energy and time. Let's move on. This is a quote from a book by Werner Heisenberg from 1930, so soon thereafter, and I'll read it in full. On the whole, the book contains nothing that is not to be found in previous publications, particularly in the investigations of Bohr. The purpose of the book seems to me to be fulfilled if it contributes somewhat to the diffusion of that Kopenhagener Geist der Quantentheorie, the Copenhagen spirit of quantum theory, if I may so express myself, which has directed the entire development of modern atomic physics. That's the origin of the Copenhagen spirit, which you could also see in the title of my talk. So my question is, what is that, the Copenhagen spirit? There's a few candidates. Could be Niels Bohr himself, right, as spiritus rector of the Copenhagen Institute and of how everything was being run here. It could be a specific style of doing physics. I mentioned this sharpening of the correspondence principle. So you take what Bohr has given you and sort of build on top of that in a very specific way. It's a very specific way of doing physics. This could be the Copenhagen spirit that Heisenberg is referring to. It could be a specific interpretation of quantum mechanics. I just mentioned complementarity and the Copenhagen interpretation. So is that the Copenhagen spirit that Heisenberg's referring to? It could also be a specific way of interacting with students, postdocs, and colleagues. You see a picture here from Auditorium A in 1922, where sort of the big professor Niels Bohr and another big professor, Paul Ehrenfest, sit together with the young assistants, and, well, they don't look very formal to me. I can't imagine a picture like that from Sommerfeld's group in Munich at that time in 1922. No way, right? This is a very informal way of interacting. Everybody had a right to speak, and the better argument won. As a baseline, right? Not maybe necessarily in 100% of the cases, but there was much more openness to hearing young students out if they had a good idea. So now we have a lot of candidates. Which one is it, this Copenhagen spirit? Well, that's my answer, all of the above. That's not necessarily true for all commentators. I'm not the first one to try and define what the Copenhagen spirit is, right? But I would say there is some consensus that it's the mix of these characteristics that make out the DNA of Copenhagen in quantum physics in the 20s and 30s and beyond. You have somebody who is really at the center of the developments, at the forefront of modern physics. You have a specific style of doing theoretical physics, a specific underlying philosophy and interpretation, and you do that by working together already with the youngest ones you have at your institute in a very informal fashion. That's sort of the secret of this place. It spread quickly. I know I'm being videotaped, so I maybe shouldn't exaggerate, but let me just say, a lot of what happens in physics departments around the world nowadays, of how research is organized and how research colloquia are being run, has to do with how they have been run at the Bohr Institute. And of course, that also means with how they have been run at Rutherford's Manchester Institute, right? And here's a nice quote in Danish language, if you don't recognize it. It's about the level I'm able to achieve in Danish, by George Gamow, a Russian, later naturalized American physicist, who writes, På Osteruge havde vi her en teoretiske konferencen in Kopenhagener Geist for diskussion af kernefysikteorien. Konferencemedlemmer var Dirac, Bethe and so on. Det var bare diskussionkonference uden reading papers, som er første forsøg af denne slags i US. Det blev meget interessant. Right? So mid-30s, this spreads to the United States. You might know George Gamow also as a prankster. He was part of this informal culture at the Institute for sure. Here, and I'm not going to go into the details, but here are some drawings he made on the occasion of the 10th birthday of the Institute in 1931. It's a history of the Institute and of Niels Bohr up until that point, with the atomic model in 1913, fishing in the murky waters of the old quantum theory, the establishment of the Institute, supervision of the young postdocs, many, many more things, fights with Wolfgang Pauli, let me go on, uncertainty, the beginnings of nuclear physics, the double slit experiment, and then, that was very recent at the time, the pondering whether or not energy and momentum conservation could be upheld in nuclear physics or not. And then if you look very closely, this is Niels Bohr's phase. That's probably Werner Heisenberg, that's Wolfgang Pauli, and this might be Albert Einstein, who knows, right? This is George Gamow's drawings, and it shows you a little bit. This was shown at the celebrations at the 10th anniversary, so there is some informal and fun culture at that place. Here you see some famous pictures. That's probably the least famous one from the 1929 Kopenhagener Konferenz. That's probably the most famous one, the one with the trumpet, the cannon, and the little electrical or like mechanical drummer boy, where you really have sort of the most famous people in physics, and also sort of the next generation of the most famous people in physics, if you think of people like Peierls or Bloch or Teller in the background. And that's another very famous picture from 1936, where you also have the likes of, I don't know, John von Neumann and many, many more, Lise Meitner, and so on. So we have many more of those pictures. You can also look at them online. What happens in the 1930s? People emigrated from Central Europe, Germany, but also Austria and other places, and they joined the Institute, not for long very often, but sort of as an intermediate stepping stone towards going to other places like the UK and the US, but also the Netherlands, France, and other places. At the same time, there was a redirection of science at Bohr's Institute towards nuclear physics and experimental biology. So atomic physics wasn't at the center any longer, especially nuclear physics was at the center. That was where so the most interesting things were happening, but also where people thought that maybe new physics was hiding, right? There were philosophical debates about the unity of science and the interpretation of quantum mechanics. Bohr came up with what was called the compound nucleus model. There's a little picture here, or like a model of this model, which was an alternative to what had been around since the late 1920s, namely the single particle quantum well model for nuclei. And in 1939, famously, Bohr and John Archibald Wheeler in Princeton explained nuclear fission, which just had been discovered shortly before. The Institute has always been an institute for experiments from the get-go. Don't let the name Institute for Theoretical Physics lure you into believing that it was mainly theoretical. The meaning of the word theoretical was actually different back then. The closest we could get to it today is probably by saying it was an institute for foundational physics, right? So the experiments were always a part of the institute, and they went big in the late 1930s. As you can see here, this is Niels Bohr in front of a generator, together with George de Hevesy. They built this Van de Graaff generator, they built a synchrotron, they built a Cockcroft-Walton accelerators, all very competitive machines at the time. So the bottom line is, during those interwar years that I now spoke about for about 10-15 minutes, NBI became the worldwide center of modern physics. What happens then? Rupture. In April 1940, Nazi Germany occupies Denmark, and the world is about to change. Part 2. That's the entrance of the Niels Bohr Institute looking towards the lakes in 1943 or 1944. There's a soldier posted there, and you probably all know this leaflet in not really Danish, probably Norwegian or something in between Danish and Norwegian, that was dropped from flying aircraft on the 9th of April, 1940. That's right next to the Niels Bohr Institute, the Freemason building on Blegdamsvej, which served as the headquarters for SS Schalburg Corps between 1943 and 1945. Here's a quote from reminiscences of Stefan Rosenthal, a close collaborator of Niels Bohr's, about these years. For a long time, Bohr succeeded in keeping the work going, even if events made dramatic claims on time, strength, and nerves. The staff shrank in numbers, no foreign visitors could come, and the few who remained gradually left the country. But mainly, it was the pressure of world events which weighed heavily on people's minds. Wherever Bohr was, at home, at the Institute, or with friends, he listened to every single news bulletin, both from Denmark and from the British radio. The general war situation and what was happening closer at hand occupied his thoughts and gave rise to long conversations and speculations about the progress of the war. Quite depressing times, and it's understandable also because of the fact that many of his collaborators had left the Institute, that physics didn't advance at the pace that it used to just a few years earlier. There's a very famous visit by Werner Heisenberg, the same Heisenberg that I just mentioned earlier. In 1941, he comes to give a talk at the German Cultural Institute in occupied Copenhagen, and this visit is a matter of controversy among historians and also among the actors themselves. There is a minimum consensus, is that Heisenberg mentioned the so-called uranium project in which he was involved centrally, and that he was overall very optimistic about an eventual German victory. And that much is also certain, both were very startled by their encounter and their conversation. So there's sort of two extreme positions in explaining what happened there. One is very close to Heisenberg's own position, and the other one is very close to Bohr's own position, as they told us about 15 years after the fact. Right? We don't know, we don't have any sources, historical sources from 1941 telling us about this. Everything is mid to late 1950s. So one of the extreme and conflicting accounts is the following. Heisenberg was driven by moral considerations and wanted to inform his fatherly friend Bohr about the peaceful nature of the German uranium project. They were just building reactors, they were not building bombs. And maybe he wanted even to inform the Allies through Bohr, or even sabotage the Nazi war effort. Bohr turned Heisenberg away, and this left Heisenberg in despair. That's basically Heisenberg's, post-World War II explanation of what happened. And also Weizsäcker's. Carl Friedrich von Weizsäcker was also instrumental in this visit. The other side is the following. Heisenberg was driven by a belief in German victory, and he wanted to enlist Niels Bohr and other scientists in German-occupied Denmark in the efforts to build an atomic bomb in Germany. Bohr was, quite understandably, horrified by the meeting and the betrayal of this trust and friendship. This is an open historical question, what really happened. We have statements by both sides, by the involved parties. Some of the most important documents are these here. Niels Bohr, in the 1950s, wrote several letters to Werner Heisenberg explaining how he remembers what happened, but he never got around to sending them off. The reason why he never sent them is unclear, but you can read them yourself at the following URL. Bohr, in 1943, 29th of September, fled the country via the Öresund to Sweden and then was taken to Stockholm immediately. A week later, he was taken on a Mosquito bomber to Great Britain, joined the British nuclear project, and then also went to Los Alamos into the United States and participated in the Manhattan Project and the building of the atomic bomb. This is one of the people who claimed that they took Bohr across the Sound. There were several. And then things became really very different at the Institute with Bohr away. We have some reports of now, finally, German troops really entering the Institute, looking for things, arresting some of the people still working there, and so on. So things got really, really rough at the Institute. Bohr was away under the code name Nicholas Baker with his son, Uwe Bohr, who bore the name James Baker. And this picture is, of course, from much later with J. Robert Oppenheimer, who was the scientific head of the Manhattan Project. This is the only photograph we have of Niels Bohr. It's not necessarily what you imagine when you think of Los Alamos, somebody standing on skis. It's the only picture we have of him in these years. Which brings me to part 3. Bohr came back in August of 1945 after Hiroshima and Nagasaki. And this is him arriving at Bleidamswey by bike. Post-war physics had really changed with respect to just 10 years earlier. Physics has gotten more global, it got bigger, more prestigious, and it diversified into subdisciplines like nuclear physics, particle physics, and so on, solid-state physics. The central research interest in the post-war was nuclear physics, and especially with respect to experiment, all of Europe was lagging behind the US and also the USSR. The old machines from 1938 to 1939, you know, like 7 to 10 years old, they didn't do the trick anymore because so much had happened on the experimental front during World War II. So what's the strategy here? Do you, again, redirect research at the Institute from atomic physics to nuclear physics and biological physics to yet another new thing? Will that help? Well, Bohr tried several things. He involved himself increasingly into politics, advocated international scientific collaboration and free exchange of ideas, also across the Iron Curtain. You might have heard of his open letter to the United Nations from 1950. And he combined this with his efforts to rebuild physics in Copenhagen and his institute, and to turn it again into a world center of physics. Maybe not the world center, but one of the world centers of physics. Copenhagen, to some extent, was still neutral, right? It definitely wasn't involved in the Cold War in the same way that some other countries were. And his strategy was to rebuild and extend the interwar network and to further scientific exchanges between East and West as much as he could. So one of the big things he tried to do is to get CERN to Copenhagen. The idea was really to get CERN to Fælledparken, At the time, that sounded like a good idea. I'm not sure we still would have enough space for these newest machines that are currently planning. But that didn't work out. It was basically a non-starter, this bid. Geneva in 1952 was chosen as the site of CERN. But as a consolation prize, if you will, this theory group of CERN moved to Copenhagen. Within a few years, they found out that's not a really good idea to have the experimentalists in one place and the theorists in another place. So the theory group moved to Geneva as well. And as a consolation prize, the Nordic countries founded what was called NORDITA, the Nordic Institute for Theoretical Atomic Physics, which started its activities in 1957. And in 1958, the Risø Nuclear Research Facility opened its doors. So you can see there were many efforts in the post-war, but the center of gravity of modern physics was moving away from Copenhagen. And this story here about CERN to Geneva, right? So is that the end of the story? Is that the death of the Copenhagen spirit? I wouldn't be standing here if that was my story. Let's look at this quote. Jerry Brown, nuclear physicist born in 1926, writes in 2001 about his time here in Copenhagen in the 1960s. Basically, I mean, he arrived here after Bohr's death. I moved to Copenhagen in the summer of 1960. Okay, sorry, I take that back. Just before Bohr's death, Bohr died in 1962. Copenhagen was at its zenith in nuclear physics, with the Bohr-Mottelsson collective model explaining more and more nuclear phenomena. Bohr and Mottelsson had built up the extremely successful Copenhagen School in Nuclear Physics. The more famous pre-war Copenhagen School still permeated the buildings of the Bohr Institute and NORDITA. Adherents of the Bohr-Mottelsson School came from all over to revel, experimentalists to fit the data. Well, all good, right? You might have noticed this is not Niels, and I basically gave it away with how I started explaining this slide, but it's his son, Owe Bohr. Let's learn a bit about Owe Bohr and his biography. He plays a central role in repositioning Copenhagen on the map of physics during the 1950s and beyond. He had emigrated together with his father, and he became his right-hand man during the war years, writing his letters, writing drafts of documents that Niels Bohr was working on, and so on. In 1946, he did a master's, then went to study at the Institute for Advanced Study in Princeton in 1948. Then he was a visiting fellow at Columbia, and there he met Charles Townes, an experimental nuclear physicist who, in the late 40s, measured electrical quadrupole moments of atomic nuclei. And the existing models of the nucleus failed to explain these quadrupole moments. Still at Columbia, Owe Bohr developed models of deformed non-spherical nuclei in order to explain these electrical quadrupole moments. And then he returned to Copenhagen. Here you see a group of nuclear physicists in 1952 in front of the Niels Bohr Institute. 3 Nobel Prize winners, 2 in physics, Owe Bohr and Ben Mottelsson, who received the prize in 1975, and Walter Kohn in chemistry. That's Walter Kohn in chemistry, much later, in, I don't remember, early 2000s, I think. So when he returned to Copenhagen, Owe Bohr, his idea was to focus on an area of nuclear physics that did not necessitate big machines, because you couldn't afford them anymore as a small country like Denmark, nor big funding in any other ways. And the solution was nuclear structure physics. It's basically low-energy nuclear physics. You don't need any big machines. You do need experiments, for sure, but they are rather affordable still. And what nuclear structure physics is the study of the many-body system of the nucleus. It's a tightly bound many-body system of the neutrons and protons inside the atomic nucleus, and you do that at low energies. You don't have to collide any nuclei, for instance, or protons and nuclei or something like that. These experiments on nuclear structure, on the spectra of nuclei, they had become much, much better after World War II, also because microwave emitters had become much, much better during World War II due to radar, right? That's where a lot of the wartime research money went into. And basically, as a side product of the Manhattan Project, quantum electrodynamics entered the scene around 1948 and 1949, which was a new theory for high-energy physics, if you will, which provided a host of new theoretical concepts. And Bohr tapped into these resources and turned his father's institute into a worldwide center for this nuclear structure physics. He was trying to do something very specific, and in order to understand that, I want to give you a quick glimpse at what nuclear physics looked like around the year 1950. This is Victor Weisskopf, a famous nuclear physicist, writing about the state of affairs in 1951. Since there exists no exact theory of nuclear structure, one is forced to introduce a number of oversimplified nuclear models in order to explain the main features of the experimental material. The models can be classified into two distinct groups according to their fundamental viewpoints. A, the independent particle viewpoint, IP. B, the strong interaction viewpoint, SI. The two viewpoints seem to be totally contradictory. So the independent particle model is what we often refer to as the shell model due to Meyer and Jensen. It's the newer one of these two. It's an analogy to atomic structure. Just as you fill up the shells in an atom, you would fill up shells in the nucleus. And it accounts for large binding energies of magic number nuclei, for instance. It's basically the noble gases of nuclei, if you will. And then there's the other class of models, strong interaction. And that's the compound nucleus / liquid drop model that Gamow, Bohr, and Wheeler and so on had been using already in the late 20s and 1930s. This accounts well for fission, for nuclear binding energies, and so on. But both these classes of models fail, for instance, for the nuclear quadrupole moments that I just mentioned. And Weisskopf's idea, which he also mentions in this paper, even though I didn't quote it, is maybe the two models do not compete, but they rather complement one another, and complement in a very Bohrian sense, right? So that they together form a view on what's really happening. And that's what Bohr sets out to do. He tries to develop a unified model combining the features of both models, IP and SI, simultaneously. He was soon joined by Ben Martelson, a student of Schwinger's who brings knowledge about QED to Copenhagen, and in a series of papers in 1953, Bohr and Martelson introduced so-called collective variables, which described the vibration and the rotation of the nucleus as a whole. And this is just what Weisskopf had in mind. Weisskopf was also a frequent guest here, I should mention that. Based on empirical knowledge, Bohr and Martelson identified the relevant degrees of freedom in nuclei, individual nucleons, that's fermions, analogous to the electrons in quantum electrodynamics, and collective modes, bosons, analogous to the virtual photons in QED, which would be sort of breathing modes, for instance, of nuclei. And then they established a formal analogy to the quantum electrodynamical treatment of the lamp shift and studied the coupling between these degrees of freedom and rewrote the many-body Hamiltonian in the following way. And this is actually sort of elementary school algebra, right? All they do is write the Hamiltonian, which is basically the total energy of the system, in terms of these new degrees of freedom, the individual degrees of freedom and the collective degrees of freedom. And what they do is they then add the Hamiltonian again and subtract these two. So if you do the math here, this equation is just H equals H, right? So it's not too complicated. But what's happening here is that sort of this contains the main physics, and this is sort of a small perturbation to that main physics. And then you can use what is called perturbation theory to some extent to make sense of what's happening in this system. That's as far as I'm going to take it here. The resulting unified model of the nucleus was extremely successful in describing nuclear structure. It combines the best of both worlds, if you will, and it rapidly spread around the world. One example is this fun thing. You might know that like every 10 years, the colleagues of Niels Bohr presented a little journal of jocular physics on the occasion of the round birthdays of Niels Bohr. So on his 50th, 60th, and 70th birthday, there's like not entirely serious journals that were presented to Niels Bohr as a gift. And this is the last one we have from 1955, and it contains a form. And that's a form for all future papers in nuclear physics. So basically, part of the text is already set in, and you only fill in the blanks. standard form TNP1 title on the blank in the unified model. Authors, several. In view of the present difficulties in giving a complete description of the properties of an assembly of interacting nucleons, we consider the following Hamiltonian, like the one I just showed you, where, and so on. One part is the collective motion, the other one is the individual particle motion, and please note also the first two references are definitely from DanMat Phys-Met, right? So that shows how, at least in Copenhagen, people thought how widespread the collective model or the unified model of Oberbohr and Ben Mottolson was already 2 years after they had published it. So Copenhagen in the post-war years remains a worldwide center in physics, just not the only one, right? Oberbohr maintains and extends his father's pre-war network by focusing on a particular area of nuclear physics. He also maintains the informal atmosphere at the Institute, and the Copenhagen physicists follow a specific style of reasoning, which is reminiscent of Niels Bohr's own Copenhagen school. Ohr is also actively involved in maintaining his father's scientific internationalism. There is famously many guests from the Soviet Union, but also from other parts of the Warsaw Pact. Bottom line, the Copenhagen spirit was well and alive, and there's two quotes which I would like to show you. The first one by Vicky Weisskopf. Copenhagen is the mecca of all physicists. Every American nuclear structure physicist of any standing must have spent a year at that place. He said so in 1966. And actually from the same historical source, there's another one by John Wheeler. If a Martian were trying to degrade mankind's ability to make progress in nuclear structure physics to the maximum extent and had only one bomb in his arsenal to accomplish this purpose, he would surely drop it on Copenhagen. Yeah, it rings a strange tune maybe these days. It's the first time in quite a while I've shown this quote. And since then, in 1975, as I already mentioned, Oberbohr and Ben Mottolson received the Nobel Prize, yet from the early 1970s onwards, nuclear physics was in demise. Globally, you could say that the Cold War physics bubble burst. Western powers in the Cold War, especially the US, but also other countries, had assumed they would need a huge amount of physicists in order to win the Cold War. In the early 1970s, they found out that wasn't so. Here you can see a statistics over the number of physics PhDs in the US collected by David Kaiser, and you can see that from about 1970, there is a steep decline in PhDs, which had to do with the fact that funding stopped, right? And the funding stopped because people way up made the decision, okay, probably we don't need that many physicists after all. And that was like disproportionately intense, the effect on nuclear physics. Since the 1990s, there was a substantial growth and a broadening of NBI's research profile. For instance, famously in the early 1990s in '93, and against a lot of protests, 3 other institutes at the University of Copenhagen were put together with the Niels Bohr Institute, the Solid State, the Geophysics, and the Astronomy Institutes. And today, therefore, in large part, the research profile of the Niels Bohr Institute resembles much more that of a normal university department of physics than it used to up until the early 90s. But just as Oberbohr had reoriented his father's institute, actors since the 1970s, and that's still very much sort of open for research, reoriented the Niels Bohr Institute through a strategy of excellence by focusing on specific areas of physics, specific so-called focus areas: quantum optics, particle physics, condensed matter and nanophysics, ice and climate, dark cosmology, recently quantum computing. In many of these areas, Copenhagen still checks most, if not all, the boxes for the Copenhagen spirit, which is informality, internationalism, culture of discussion, and openness. I have a conclusion slide here. The Copenhagen spirit is not one single element, but a range of elements of scientific practice which derives from Bohr's legacy. For instance, neutrality, internationalism, informality, discussion culture, openness, embedding into networks, specific styles of research and of interacting with students. And those are not merely values in themselves, but they actually serve and have been successfully used to further research at the Institute and also in science in Denmark as a whole. In the interwar period, Niels Bohr skillfully turned his institute into the birthplace of quantum mechanics and the center of modern physics, open to physicists from both Allied powers and the Central Powers of World War I. This status got lost in the post-war years, but Bohr nevertheless managed to keep Copenhagen centered on the map of physics by developing it into a center for nuclear structure physics. And despite the demise of nuclear physics since the 1970s, many elements of the Copenhagen spirit, if not all, still pervade the various groups and centers at the Niels Bohr Institute. What a nice picture for the Copenhagen spirit. Niels Bohr and his wife in Tisvilde on a motorbike. If you want to know more, do read these very fine books by Peter Robertson on the early years from 1921 to 1930, and by Finn Åserud mostly on the 1930s, but also beyond. And if you want to know more about Niels Bohr, read these nice books, biographies, and more in-depth look at the Bohr model of atomic structure by Helge Krauw. And I want to thank you for your attention and very much look forward to your questions in either English or Danish. Thanks.